Alright, so we're going to talk about solving polynomial equations. So we've solved linear equations, we've solved quadratic equations, so now we're going to look at how to solve higher degree equations. The fundamental theorem of algebra says that anytime we have a polynomial function, p of x, and we set that function equal to 0, that the amount of roots we're going to have is going to be equal to the highest degree of the function. Now this also includes multiplicity and complex roots that include the number I. So before we actually start trying to figure out how many roots we have, you want to make sure you're in standard form. So once you're in standard form, you just look at the highest degree, and that's how many roots you have. So for this first example, our highest degree is 5, so we're going to have 5 roots. And that's going to be a quintic function. For the second example here, you can see that the highest degree is 3. It's a cubic function that's already in standard form. So we're going to have 3 roots. Now, given the roots, you can also figure out the degree of the function. So, in this example, you can see we have 0, 1 multiplicity 2, and 3. So 0 is 1 root, 1 multiplicity 2, that actually counts as 2, and then 3. So we're going to have 4 roots, which means this is a quartic function. And then this final example, we have negative 1 and then plus or minus I. Now remember, plus or minus I means I and negative I. So it's actually 3 separate roots, and this is a cubic function. So remember, we call this many names. We say zeros of the function, we say solutions to the equations, we say roots. All of that means the same exact value. We set it equal to 0, we put y equal to 0, and we solve for x. So that's what we're going to be doing, but for higher degree polynomials. In order to solve a polynomial equation, we're going to be putting our function in standard form, then we're going to factor using the different methods of factoring that we've learned, and then we're going to set each of the factors equal to 0 and then solve. We're going to be using our knowledge of solving quadratic equations to help us solve higher degree polynomials, so please make sure you refresh your memory on these different methods. We also need to recall how to factor, so hopefully you have your handy dandy factoring flowchart and you remember the different ways to factor and when each method is appropriate. Now we're going to solve this higher degree polynomial. The first thing we have to do is make sure that it's in standard form, so we're going to bring the 1 over, set it equal to 0. Now we need a factor. Now this is a difference of 2 perfect cubes, so we have our small parenthesis, large parenthesis, set equal to 0. To factor this, remember, we take the cube root of the first term, so that's x. We have the same sign as our original problem. Then we take the cube root of the last term, which is just 1. To find the first term here, we take our first term here and square it. Then the sign is always going to be the opposite of what we had originally, so our sign now is going to be plus. To get the middle term, you multiply these two together. And to get the last term, you always have a plus, and then it's the square of the second term here. So remember, this guy is always a plus, this guy is always the opposite of that one. These are squares, and this one is these two multiplied together. And if you need to refresh yourself on factoring perfect cubes, go ahead and make sure you look at your factoring flowchart. Now the next step is to set each of our terms equal to 0 and solve. So this one's easy. X minus 1 equal to 0. X is going to be 1. Now this guy here is never ever ever factorable. So you always have to use the quadratic formula or complete the square. You can never factor this guy ever. So using the quadratic formula, a is 1, b is 1, c is 1. So that's going to have negative 1 plus or minus the square root, b squared minus 4 times a times c, everything over 2a. Simplifying, we get negative 1 plus or minus 1 squared is 1 minus 4 all over 2. Negative 1 plus or minus negative 3 over 2. That negative means there's an I in there, so I'm going to hop the I out, all over 2. So there are my two solutions. So altogether, I have negative 1 plus or minus I radical 3 over 2 and positive 1. Now let's double check here. This is actually two solutions. This is negative 1 plus I radical 3 over 2 and negative 1 minus I radical 3 over 2. So that's two solutions, and then I have 1. Now, did we start with a cubic? Yes, we did. So remember, 3 solutions means that I should have a degree of 3 in the beginning, and I do. So the first step is to make sure we're in standard form, so I'm going to go ahead and bring the 18 over. Now we need to factor this guy. So hopefully you remember how to factor the higher degree polynomials. We're going to treat the x to the fourth like it's an x squared. Treat the x squared like it's an x. So you could use substitution, or you can hop right into factoring. So the factors of x to the fourth are going to be x squared and x squared. The factors of 18, well, that's 18 and 1. That's 9 and 2, and that's 6 and 3. Which one will add or subtract to give me 11? That's going to be 9 and 2. Same sign, both negative. Now the next step is to set each of these factors equal to 0 and solve. So x squared minus 9 equals 0. You could factor, but I'm going to use the square root method. So x is going to be plus or minus 3. Second parenthesis, x squared minus 2 equals 0. Again, square root method. So x equals plus or minus 2, square root of 2. So writing my solutions, that's plus or minus the square root of 2, and that's plus or minus 3. Now you could write that out as 4 separate numbers, or if you're aware that these are two numbers, you can double check your work and say, well, I have 4 roots, 4 solutions, and I started with a degree of 4, so I know I have all the roots that I need. Alright, so I want you to go ahead and try these on your own. For the first part, you're going to be telling me how many roots does each polynomial function have, so make sure you're in standard form and in simplest form. For the second part, you're going to be classifying by degree, so count how many roots we have and then classify it. So is it linear, quadratic, cubic, quartic, quintic? Please use correct vocabulary and put those answers in your Google form.